All right, guys, let's take a look at number 11 here in 1.5. They've given us a rational function right here. F of x is equal to 1 over 7x minus 3, and the directions are a little wordy. First, they want us to find a domain on which f is 1 to 1. So I think I'm going to graph this thing here real quick. And what I think I see looking at this is that we have a vertical asymptote right here at, let's see, if I set my denominator equal to 0, I'd get x is equal to 3/7. Kind of an ugly number right there, but okay. So there's a vertical asymptote here somewhere, and then we've got a horizontal asymptote at y equals. Now the numerator is constant, which is a degree of 0. The denominator is linear, which has a degree of 1. And when the degree of your numerator is less than the degree of your denominator, that's when you have a horizontal asymptote at y equals 0, or the x-axis. So there are the two asymptotes, and if we thought about just a couple of points right here, like for example f of 0, that is going to get us a 1 on the top and a -3 on the bottom, -1/3. So I get a point that's located right about here. That tells me that this hyperbola exists in the lower left-hand quadrant formed by my two asymptotes. Now I think on the other part it's in the top right, but let's find out here. What if we did f of 1? That's going to get us a 1 on the top and a 4 on the bottom. So 1/4, so 1/4. Yeah, the actual details of this, guys, and the spacing aren't really important. We're really just trying to find out what quadrants this thing exists in. Now, the whole point of graphing that is to find out where, if anywhere, this function is 1 to 1. And as I think about the horizontal line test, let me switch to green here real quick. If I drew a bunch of horizontal lines here, what I think we'd find pretty quickly is none of those horizontal lines cross the line, the curve, the blue function right there, more than once. So this function already is 1 to 1 on its entire domain. Its domain then would be everything other than 3/7. So answering the first part of the question, I think we can say that f is 1 to 1 on an interval that begins at -infinity and goes all the way to 3/7. Parenthesis there. And let's see, at 3/7 the function doesn't exist, so we're going to put parentheses right there, and then we'll do a union of that set with another set from 3/7 to positive infinity. And that would be my answer to the first part of this question. In some subsequent questions, we're going to have to basically chop off part of the function in order to make it 1 to 1 for a while, but here we got to avoid that. Okay, second question they asked, find a formula for the inverse of f. So this is what we've been doing for a while now. We start off by switching x and y. F of x was y, and it now becomes x. That equals a 1 over 7y minus 3, and now we try to solve for y. This is where I'd probably do that trick where I can take the top of the left side of a proportion and the bottom of the right side and just trade places. It's kind of killing two birds with one stone here. So we get 7y minus 3 equals 1 over x. Now we're just trying to solve for y, so we begin now by adding a 3 on both sides, but I think it would be a better idea, rather than doing this, to think of that 3 right there as, still wanted that to be red, to think of that as 3x over x. Why? Because that gives us a common denominator right here, but we can do it because the 3x over x still has the same value as 3. So 7y equals, and this will now be a 3x plus 1 all over x. And the last step now would be to divide by 7. But remember that dividing by 7 is the same thing as multiplying by its reciprocal, 1/7. And we end up with y is equal to a 3x plus 1 all over a 7x. Okay, so again, the directions now set. Find a formula for the inverse of f restricted to this domain. So we have another rational function right here. My issue would be, should I call that f inverse, stating that it's a function, or just leave it as f here? Well, I'm pretty sure that this function right here, in fact, no, I know the answer already, that this relation we just came up with is a function. And why? If we go back to this graph right over here, if you take a look at all those green horizontal lines, that tells us that f was a 1 to 1 function. And if f is 1 to 1, then its inverse is a function. So I really can call this thing now f inverse of x, and that's probably the better way of naming that answer here rather than just calling it y. Okay, so that's the second part right now, the formula for the inverse of f restricted to this domain, and then it wanted us to graph both of them. So let me go back to the graph that I had every one of these green lines I got to move manually here. Okay, so, all right, let's get all of that junk out of the way right here, and now let's try to graph. Can I do this? Yeah, there you go. Now let me switch to purple. We're going to try to graph this function right here. All right, guys, vertical asymptote. Take a look at your denominator right here. That one will not exist when x is 0. Our horizontal asymptote, all right, we have a linear function on top, a linear function on bottom. It's a tie. So we have a horizontal asymptote at y equals the quotient of your leading coefficients, 3 and 7, so we get y equals 3/7 for our horizontal asymptote. So, tell you what, let me switch that to green. Vertical asymptote right here at the y-axis. Horizontal asymptote at y equals 3/7. And then from there, real quick, if I were to evaluate, let me get my notation right, f inverse somewhere to the left of my vertical asymptote, like -1, let's see what we get. 3 times -1 would be -3, plus 1 would be -2, over 7 times -1, -7, and that's 2/7. So we've got the ordered pair -1 and then 2/7 right around here. Now focusing on my green asymptotes, this graph is going to exist, oh boy, somewhere like that. And let's pick something to the right of our vertical asymptote now. Let's evaluate f inverse at +1. That numerator, 3 times 1 plus 1 is going to be 4. My denominator, 7 times 1 is going to be 7. So we've got the ordered pair 1 and 4/7. Okay, so 1 to the right here and 4/7. That dashed green line right there was 3/7. 4/7 would be just above it. So this graph is going to look something like that. Okay, and this is weird and a little hard to see because everything is so closely clustered together, but I should be able to draw the line y equals x, which is going to be a dashed vertical line right here, and see that I got this one pretty close to right, that if I took the blue graph and folded it over the black line, that would match up perfectly with the purple graph. And as I said, they're so close together that it's kind of hard to see that, but that does actually work out that way. So that's everything we needed there for problem number 11 in section 1.5.